coefficient analysis for a situation that is like this, right? Because n can be 1, 2, 3, 4. That means within this expression itself, there may be some hidden patterns. If I cannot see the pattern, then one way for me to see it is to set up a condition. The condition is very easy. Just make sure that you see the individual terms. So let's try, okay? So what if n is equal to 1, for example? If n is equal to 1, then we are going to be seeing cosine of 1 times pi. Cosine of 1 times pi is going to be equal to cosine 1 is going to be equal to minus 1. What if n is equal to 2? N is equal to 2 is cosine 2 pi. Cosine 2 pi is 1. If n is equal to 3, then we will have a cosine 3 pi. Cosine 3 pi is going to be equal to minus 1. If n is equal to 4, cosine 4 pi is going to be equal to 1. If n is equal to 5, what are we expecting here? Minus 1. Then we're expecting 1, we're expecting minus 1. This is when I know I'm already starting to see the pattern. This is exactly what I'm hoping for. I want to see the pattern. And in order for me to see the pattern, my aim is to just trying to set up a condition. The condition is giving myself the chance to see the pattern. Pattern is not learned through H2 Math. H2 Math teach you to use method of difference to set up a condition so that you can see a pattern. Method of difference is just trying to list down all the terms so you can start to see the pattern of cancellation. So that's what we are deploying here. And I see plus 1, minus 1, plus 1, minus 1, plus 1, minus 1. So I can apply it here then, right? Which means that I am suspecting that my solution here is pi over n squared for minus 2 times of minus 1, or the other solution is going to be pi over n squared for minus 2 times of 1. So this is going to give me a pi over n squared and a 6, or the other one is going to be pi over n squared and a 2. So A can be either 6 or 2.